Okay, so number 7. I need some help.
Yeah.
Sophia, can you help me with this, please?
So I did the substitution method, so I did u equals x squared.
Okay.
And then I put it on my own, so I got u squared was 13u plus 36 equals 0.
Equals 0, cool.
And then I used -9 and -4, so u minus 1 times u minus 4 equals 0. So u equals 4 or 1. And then I did both of those, so x squared equals 4, which is x equals plus or minus 2, and x squared equals 9, which is x equals plus or minus 3.
You. Are we good with this?
Yes.
Nicely done. What are these kind of problems called? Quadratic in form. It's not quadratic, but you could change it to quadratic, just like Sophia did. Thank you very much. For number 9, I need some help. Walker. Nice. Can you tell us the end result? Oh, is 2u.
Squared plus 10 minus 3 minus 13.
Oh, just give me the end result of the factoring.
2u minus 3 times u plus 5.
Okay.
Then I substituted the one x to the third back in for u. So I had 2x to the third minus 3 equals 0, and x to the third plus 5 equals 0.
Nice.
And then you got x equals 27 over 2, and x equals -5.
7 over,
2.
let's see, because it was x to the 1/3 equals 3 halves, right?
Yeah.
And then to solve for that x, what do you have to do to both sides? Oh, I see. We don't multiply. We have to, like, if this, well,
You get rid of the exponent, and you multiply the exponent.
exactly.
By you cube.
You have to cube both sides. And you're correct that those exponents now multiply together. But when you cube the side, you can't just cube the top. 27 over 8. Are we good with these? Is that -125? Is that possible or is that extraneous? There can't be extraneous for these? Why not? I told you. Okay. So what types of equations have extraneous solutions? Radical equations and rational equations. Okay, good. Number 9. Birdie, help me out, please. Okay. Okay.
And then when you take away the opposite algebra, it has to be plus or minus 2, then the x is equal to plus or minus 2. And once you divide that, you get x is equal to -2/3 or 2/3.
I like how you separated it. 4 2/3. Any questions? You can write it as 1 with a plus or minus is fine. Okay, shall we move on? Oh, I do have a question for you. Would you please discuss with your neighbor if they know this symbol and this symbol?
Oh, it's like
No, it's like this versus like this.
This one is called union. I know that's a hard one to remember. If you write the symbol as a U, it's incorrect. It's you wish. Just that it's like a bowl. union, and this one is, of course, intersect. Intersect or intersection. Okay, well, those will come up in today's lesson. So I just want to make sure that we have that in our belts. Interval notation. This is used when each element of a set can't be counted. So this is used when each element of a set can't be counted. We spoke about sets in this class, didn't we? Let's bring back some of the good memories. Would you please discuss what sets do you remember from this class? Discuss with your neighbor. You ready? Fiona, what do you remember about sets? Which do you remember? Rational, real, irrational, you said. Okay. Real, whoa, nice. Were there any others? Oh, imaginary numbers. I don't think we talked about those in sets, but those are definitely different type of numbers. Integers, yeah. So I was trying to write quickly. Um, I think that this hits it. Would you all show me the lowest natural number? The lowest natural number is, of course, 1 as opposed to the lowest whole number, 0. And the symbol that we use when you're writing all these numbers, if you're indicating those sets, starts with this, yes? Anytime when you can count them, then you would use this. And these symbols are called races. They're called races or curly brackets. Okay, today we're using interval notation. How many numbers are between -2 and 3? Would you check with your neighbor quietly? How many numbers are between -2 and 3? Show me how many numbers are in between -2 and 3. Show me how many numbers. Interesting. It seems like a lot of people are saying how many integers. I didn't ask you how many integers are between -2 and 3. That answer would definitely be 4, wouldn't it? But I'm going to ask about how many numbers. Yeah. Take a look at this back corner here. That's what they're doing. Right, this is symbol for infinite number of solutions. So it would be inappropriate to try to write all of them, don't you think? You can't even start writing them. Like, what number do you begin with? Write all of them. Negative 1.9999. There is no smallest number, so we have to just use interval as solution. But I hope that it makes sense that this is how to write about it algebraically. That makes sense. It's the exact same thing. And to read this, it's not an English class. When you read this, you start with x is between -2 and 3. Not inclusive. So I'm going to start with C, and I'll let you do A, B, and D. For interval notation, I write the beginning, I write the end of my interval, and I have to indicate somehow if I'm including the endpoints. For -2, I do include it, so it's going to be a bracket. That 3 is not included, so I'm going to write a parenthesis.
That's like building circle versus the non.
Perfect. Exactly. So open versus closed. So let's see, check if you and your neighbor could do A. Well, just A and then go on from there. Yeah, why not? Let's do all. Should we do up to what was it? Should we do A, B, and C?
Yeah.
And A, what do the outside of this interval look like? What is it? They're both parentheses. One, please. One, please. Okay, so it looks like this, which is of course confusing because it appears to be. It looks like an ordered pair. So how are you supposed to tell the difference between an ordered pair and interval notation? Context. For B, the same numbers are there except brackets. That just means it actually hits the number. Of course, for C, we're going to start with open and end with closed. You got all these, didn't you? The question is, what happens with E? Yes, Lucy, you have an idea? So are you telling me we never get to infinity? Do we? Is there like a point at infinity? Okay, so I'm gonna put a parenthesis or brackets. Parentheses, because you never get there. If you don't get to a number, you have to put parentheses. And infinity, is this the first infinity you're writing in a math class? Is that kind of fun? Oh, you've done it before? Oh, dudes. Do you do the 2 zeros or you just go? Yeah. Like you don't ever practice this on that elementary school paper with the dashed line in the middle. Do kids still practice on that paper?
Yeah.
Do you have that with this and the dash dash dash? You have them. For cursing. Not for printing? Oh, interesting. How many people never learn cursing? See, all I think there was a time that I took that. Interesting. Yeah, but I know that you never talked about infinity. I just made a little wonder character. Thanks. Okay, I think you can do the rest. I'm gonna give you one more. I'm gonna give you J as well. Gee, how should I begin this one? Parentheses. Well, infinity is over there. Negative infinity. We have to differentiate. There are two different directions, however. Negative infinity, comma, 1 with a bracket. If you try to do infinity, comma 1, what you're saying is that for some reason you're starting over there, you're going to the right because it's just backwards. This is always numerical. Thank you. It's got to be from negative infinity from all the way over there up, so. One.
But why are we, why would it want? What's part of it?
Because negative infinity is down this way.
Okay.
And we're going from left to right. Yeah. I think so. Let me check the number line. Yes. Left, right, always negative. Yeah. But how about if you have two negatives?
So.
It's a resonance. Yeah, it's. Okay, so H is the same thing except. Yeah, parentheses there. For I, from negative infinity up to regular infinity. Oh, that's a pretty infinity. Look at that. I should make a font as that. Oh, thank you. Yeah, like that's true. It does not. The Incredibles. Okay, so if I'm doing J, how would I use that with? Should I use that? That would make sense. If I say negative 2 like this, interesting idea. Well, is interval notation appropriate for this? Why not? Yeah, it's not an interval. And you could count these, right? There's just two. So it's negative 2 and 3. And what should I put around them?
Like, that's it. Like, that's it. Brackets.
What do they call it?
Braces.
Braces. Yeah. But that would be appropriate for the braces because you could count. See? Hey. Okay. There's definitely a typo there. Wouldn't you agree?
Yeah.
Because as it is, it makes
No sense.
no sense. It should be -1, comma 4. That's asking you to write it in set builder notation and graph it. Let's graph it and then let's talk about what set builder notation is so that you can actually do it. So graphing it. What's up with the -1 before the 4? Do I care about where 0 is? I care about where it is, but I'm not going to mark it. All I care about is really that -1 and 4. At -1, we're going to have what kind of a circle? Open circle 4. Should I darken in the section in between? You can if you want. It takes too long for me, so I just do this. Are you familiar with that? Yeah. Okay. Set builder notation or formal set notation looks like this. It's pretty amazing. Starts with your favorite bases. Also, another thing that you probably never learned in elementary school, how to write that or how to draw that. Very fun to draw. So, does anyone know how to do that? Study this? Now, it's like, okay, I'll say how to say. Yeah. It's not a half absolute value, I'll tell you. No one studied this before. This is read X. The big line is called such that. With a dot? Not for formal segmentation. I think in other contexts. X such that. How would I? Yeah, if you're reading this with three arguments, we don't read it from left to right unless we're trying to tell someone what to write down. But when you're just conversationally, like at a party talking about this situation, you have to start with X. Describe X. X such that X is
Less.
We're gonna go from left to right.
Greater
It's
than.
greater than -1. What's the word after negative? And is word, not but, like we're not saying but. And less than or equal to or I could say x is between -1 and 4, not including -1, including 4. I don't want to write all that down, but I hope that makes sense also. Okay, that's fine. You probably won't have to write down a verbal, but I just want you to be able to communicate with friends if you talk about inequalities. Okay, I don't want anything to get left out. So B and C, go for it. Graphing it, writing formal set notation, also called set builder notation. Oh, got B, I imagine. Um, for C, which way am I going? I know I have an open circle there, -4. Which way am I going? Right. To the right, towards infinity. And when I write that down, it's gonna be x such that x is greater than -4. No? Oh, do I need to say less than infinity? It's implied. If I say x is greater than -4, that means it's going off. Oh, thank you for pointing that out. Yeah, even though -4 is first here, we're describing x. So it needs to say x is greater than -4. X is what's that? I will take off points because otherwise you're describing -4. You don't want to say -4 is less than x. Like we're talking about the unknown thing. Like English wise makes sense, but mathematically the unknown is greater than 4. Yes. Just like if you answer 5 equals x, please don't. X equals 5. I'm trying to teach you some good habits in this class, as well as being correct. Okay. Oh, we haven't seen such things before. We use graph to find each such. You use a graph. Useful. Yeah. Let's use different colors. I'll put an A in there, but it just seems like caveman without it. One, four. C one and B are fairly similar. So have to make your graph discuss with your neighbor. Pardon? You can just do it. You can do it.
One of them, all the, I think all really not. Yeah, there's gonna stop. Yeah, it's
Wait on the choice. Wait, what's the? Yeah, it's with the graph and two. Just.
Okay, so for A, we start at 2 and go to. Let's see. Let me get some big. Start at 2 and go to. I should go to up to 8. Now, another word for intersection is overlap or and. So we're looking for numbers that are in both of these sets. So the numbers that overlap. So am I going to include the 2?
Yes.
Is it included in both?
No. Wait, what?
Is 2 included in both sets?
Yeah.
Yeah, we include it. Is 4 included in both sets?
Yes.
4 is included in both sets? Really?
Yeah.
It's not included in 4, so the intersection is 2 all the way up to 4, but not including 4. That is the intersection. And if it doesn't otherwise say it, please make sure to write your answer in interval notation, or you can graph it. Yes.
So we don't have to write that sentence. Yes.
You could do formal set notation. We have 2. Do like this with the braces, of course, if you like. If you just want to do regular algebraic notation, that's fine too. If it doesn't indicate, just do it correctly. Yeah. Any one of those is fine. B, is this answer the same?
No.
So for B, we start with 1 and go all the way up to, really, including 8. Yeah, another word for union is or. So this is, and you're looking for all the numbers that are in first set and the second one. And for unions, you're looking for all numbers that are in either the first one or the second one. And even the overlap does count for or. All those numbers in the middle are in one of the sets at least. Of course, 1 is not in. I'm just going to do this in notation. Yeah. Yeah. Depending on what it says. It's unfair here. And the graph is our work, and then it's up to you to write your answer in a way that makes sense. Just interval notation is a very clear description of the answer, so that's fine. And it's almost uncomfortably ambiguous. Any one of those is fine. Properties of inequalities. You must remember from Algebra 1 that there's something you need to be careful of when you're solving an inequality. Now, I don't want to hear it, but very quietly discuss with your neighbor what's the thing you need to be careful of when solving inequalities. What's that thing? What we have to be careful of? Dividing by a negative. If you do that, then you have to reverse that inequality. Either dividing by a negative or multiplying by a negative. Okay. Do you know why that is? It makes it the opposite. Nice. Does that make sense? Let's do an example just to make sure we're on board with this. Let's say that A is less than B, and we have a number line. You don't have to write this down. This is just in your head. That means A will be like over here, and B would have to be here. Yes? So with your left hand on the number line right in front of you, with your left hand, I want you to grab the A coordinate like this, and then grab the B coordinate. Now, if you're adding something to both A and B, what's going to happen to these coordinates? You're adding something to both these coordinates, won't they both kind of slide up? So the order hasn't been changed. If you subtract, I go this way. Now let's say that 0 is over here. And now you take your A and B, you multiply them by a positive number. What's going to happen? Multiply them by a positive number. A is negative, B is positive. Want to do this? Want to do that? But imagine if you multiply it by a negative, what happens? Right, the two quantities reverse. Right, but that's if 0 is in the middle. What if 0 is like over here? What if they're both positive? So we still have our A is less than B. And you take both of these and multiply them by a negative. What's going to happen? It still reverses order, doesn't it?
Yeah.
Right, it's just like the A is little negative and the B is a bigger negative. So when you multiply or divide by negative, because they're technically the same thing, they reverse order, right? You get that property. So it's not just because your teacher told you, it's exactly what Charlotte said. The quantities become opposite of what they used to be. So the relationship is opposite. So when I talk about properties of equalities, should we just write when you multiply or divide by a negative, reverse it, reverse the inequality? Do you need to write that down or is it already in your brain? You can write it down, it wouldn't hurt. When multiplying or dividing, I had the whole thing. Reverse the inequality. Okay, try A and B. Pass back. Did you get them? Says write your answer in interval notation and graph the solution on a number line. Did you do that?
Oh, that's.
Example 4. Yeah, do you know what that is? I'm calling someone just a second, so please make sure that your neighbor is okay with this. Yeah. Or a Charlotte, tell us what you did, please.
Wait, no, I subtracted 3 to both sides.
Okay.
And then I got negative 2x. So it's greater, there's less than or equal to 8 divided by negative 3. X is greater than B.
Okay. And interval notation is what it's called. So we're going to begin that with braces. The curly braces. Oh, I see. You're doing the set builder notation. Oh, you're going above and beyond. Okay. Mhm. Okay. Nice. Nothing wrong with that. Okay. Interval notation. Let's graph it first. Let's graph it. Because we know from -4, it's going to be right there. We know it's going to be an open circle or it's a closed circle. Closed circle, and then we graph to the right or left. Okay. I want interval notation now. Okay.
Oh, sorry.
No problem. Interval notation, I just want the two numbers. Are we good with that? Thank you. Did anyone do it differently? Because it is kind of nice to do this a little bit differently. Just instead of move the 3, how about we add 2x? Would that make sense? And subtract 11? And then 3 minus 11 gives us -8. Isn't that kind of nice? So you don't have to worry about the whole divide by negative thing. And then we just divide by that 2, so we get -4. Is this the same answer? We still have to flip it. I want to know what the unknown is. So I do want you to write x is greater than or equal to -4. So it's hard to get out of it, but there's nothing wrong with collecting the x's on the other side. So for B, Jake, help me out here, please. Subtract 4 from both sides? Why are you subtracting 4?
Oh, add.
Oh, you add 4 to both sides. Okay. And do what else?
Subtract that.
I see. Okay. So something like that. I like the 2 and 1.
X is less than negative.
Okay.
Underline -3 with the open circle and go negative.
Okay. And interval notation?
Oh, it's -3 is a parentheses, -3. It's
This would mean it starts at -3. So it doesn't start at -3, it starts at -infinity.
parentheses on the.
What do we think?
Yeah.
Nice. Thank you. That interval notation here. If you don't love it now, don't worry. You will love it. It's great. It's very, very efficient. For C, would you just discuss with your neighbor what's a good first step here? What 3 words am I hoping for? Multiply by 12. Okay. Can we skip that one? Okay. And we're gonna skip D too. Let's talk about example 5. Try both of them, see what you get. Oh, example 5. Yes. When you can't solve something, inconsistent. Okay, so here we get 2x, bless you, plus 8 is greater than 2x plus 3. And of course, the next thing you notice is that the 2x's say adios. We're left with 8 is greater than 3, which means... Is that what they teach you in middle school, all real numbers? Yeah, x could be any real number, but yeah. So when it says solve, it doesn't tell you what kind of notation to use. What notation shall we use? Interval, which means we start at negative infinity to infinity. And B, it's not far before we see that x as 7 is less than -2. So again, all real numbers. No, there's a huge difference here. 7 is not less than or equal to -2. So it's giving us a false statement, which means we have no solution. You could write it like this, no solution. What symbol could you use for no solution? 0 with a slash. And very often you'll see that in a set. That's called empty set or null set. Any one of those is fine. Now, some people do write their zeros with a slash through it. If you're one of those people, make sure that none of or all of your other zeros have a slash through it. Otherwise, I'll think that is a 0. Okay, moving on. Compound inequalities. Compound involves 2 words. What are the words for compounds? Do you remember? And or. Is example A an and statement to an or statement? Yeah, this quantity here is less than -3 and it's greater than -3. That's why I put it all together. I think you can solve that already. I'll give you a moment to do that. And I ask for some help in just a few seconds. Lucy, can you help us with this one, please? Okay. Interval notation? Or do you want to graph it first? Okay. I feel like -2 and 1 would be important. Are we okay with that? Yeah, please respect the order of the number line. Okay. Well, here it says that x is right. It's the allocator. But graphically, we're going to the right here, because x is greater than -2, and x is less than or equal to 1, which means from here we go to the left. So that's our compound inequality there. And then interval notation, of course. Are we good? Thank you, Lucy. I'm gonna skip B because I think you got it. And I fixed an error in C. That first inequality was going the wrong direction. Multiply that second one by 3. You don't have to, but I highly recommend it. Did I get these right? X is less than -3 or X is greater than 3/2. So does that match yours?
Yeah.
Okay, so on a number line, we're supposed to be graphing these. So the numbers I care about are -3. The circle goes there. 3/2. Closed circle there. Goes to the right. And interval notation. Please discuss with your neighbor if you haven't already. How are you going to do this? Yeah. Otherwise, it's too strange. Do you know what to do? You want to hazard a guess? What do you think, Missy? So, guys, I'd like to hear Lucy's idea for interval notation. What do you think? Ah, let's worry about what's in between. I know that. Before we get there, I hope it makes sense that we need 2 separate intervals here, don't we? They're 2 separate sets of numbers, so we have to be here, and we have to be over there, and we do have to either use intersection or union. Please discuss which one would be more appropriate for this.
So I guess that's what I should. Oh, nice. And what intersects of those two? It's just like.
So what do you think? What do you think?
Union.
Which I want to see everyone's. Is it union or intersect? Why am I saying this union?
It's a or.
It's a voice statement. If it's an intersect, that means there wouldn't be anything. That's all the numbers that are here and here. They don't exist. There's no intersection. This can only be a union. Are we good with that? Any questions? Okay, let's do D. Okay. You need to discuss this with the neighbor? Because you rewrote the left side, didn't you? How are you supposed to do this? Liv, do you have an idea? Because you can try to multiply both sides by that bottom. That's not helpful. Can we do 0 to -1? I don't know if that works. But how do we get out of this? I don't know. Square. There's no square root here, so much.
Isolate that.
Well, what's one way to say this right here? Positive, right? So we just want to make sure that this is positive. How can we make sure that that whole quantity on the left is positive? Well, 1 is already positive. The top is already positive, which means the bottom just has to be positive, doesn't it? Analytically speaking, does that make sense? That we just have to make sure that that's positive, and that'll get us there. So, analytically speaking, we're just making sure this fraction's positive. We have a positive on top. If the bottom's negative, that's not going to work. The bottom must be positive. So we have to use a little bit of analytical thinking for that one. And from there, I think it's probably not too difficult. Now you solve it normally. And I'm going to trust you to do that on your own. So next time I see you, I'm not finishing yet, but next time I see you, we are going to have our quiz. That quiz will not include that which I'm about to talk about. I'm not going to be able to have time for a full lesson, but I want to at least give you an introduction here. Right. So up to what I do right now will be on the quiz. I'm going to put 2 different questions here. Yeah. And I'd like you to think about what the solutions are for these 2. And discuss with your neighbor. What are the solutions for both of these absolute value inequalities?
It's supposed to be other items.
Yeah. So it's either makes 2 or
Okay. For that first one, what are the solutions? Do we agree 2 and -2 are solutions? Okay. Are those the only 2 solutions? Everything in between? Do we agree with that? Including these endpoints? What's a good way to summarize this? Using what kind of notation? Interval notation would be a really good summary here. -2, 2. But the second one, who'd like to tell us what they came up with for the guys? The solution for this absolute value of x is greater than 4. Extraneous. Oh, there's nothing? Really?
Solve an absolute value and it's like an equation. It's -4, but -4 is extraneous.
Okay. So -4 is definitely not part of our solution. How about 4? That's a good point.
so it's extraneous.
Ah, so 4 is extraneous. Well, extraneous means we can't use algebra to get a number. So, yeah, Lucy, you have an idea here? I feel like Wait, so you're saying there are solutions? Like where?
One arrow from the negative pillar,
Oh,
to the left.
is this true that all these are solutions? Is it true that all those over there are solutions to this? Yeah. Uh-huh. So these are all the solutions to this.
Yeah.
I buy it. Can you write that in interval notation, please? Of course, I like it. Make sure your neighbor got the same thing you did. Same thing you did.
It's like how the intersects.
Hey, Jaden, can you tell us how you did this?
The second.
Yeah, in interval notation, how do you write it?
I haven't written it yet, but that's it doesn't.
So there's a U in the middle. Okay.
Yeah. Parentheses.
Yeah.
Do we agree?
Yeah.
Okay.
And then the other one is 4, parentheses.
Nice. Good work on the fly.
Yeah,
Get all this together. Any questions? I want you to think about this with regards to the way you thought about absolute value in elementary school and middle school. In terms of definition as distance from 0. Let's think about that. If this one is the distance from 0 is less than or equal to 2, does it make sense that those are the solutions? Right? Aren't all these points less than or equal to 2 away from 0?
Yeah.
As opposed to this one where the distance from 0 is. Does that make perfect sense? I have a 0 there. The points are greater than 4 away. What was it? And then yes.
I have a question. So, like, would they never be upside down? Would they just always say intersect? So
Exactly. For interval notation, it wouldn't make any sense to use the intersection. Nice. It's already implied. We're not going to say intersection of this and this one. Just summarize the overlap.
yeah, so that matches.
Yeah, it's already done. Good. Thank you. So if you include the intersection for interval notation, bad things are coming. But I do have some good things coming. And we're gonna do more with this next time. I just don't want you to. I don't want to do too much today. But one more thing, something we haven't done in a while.
Oh, the scenario.
The scenario. Yes. Let me turn off the Zoom first, so.